Central Michigan University Spear Point team. I'm Austin Mowry.
Kevin Morse,
Megan Bourdon,
Stephen Barber,
Emmanuel Arrington,
Matthew O'Connor.
and here is our spear.
Our spear designs were inspired by the Mbandi people. They came from what is now present-day South Sudan. In the 18th century, the Mbandi of Bandia clan conquered Zandi areas, assimilating their culture and creating a series of states in an identical language. The Mbandi were once renowned warriors. Their smiths created high-quality lances and knives that were traded with many neighboring groups, which are now coveted by collectors of African art. Our design took inspiration from the Mbandi people and their leaf-shaped spear head points.
Because our spears are modeled after the Namandi tribe, we modeled our spear after the third spear from the right. In Autodesk Inventor, a spear was drawn up and was subject to 3 areas of interest: applied torque, applied load, and buckling. The final length of the drawing was 18.5 inches, and the shaft was designed to fit over the Liebman handle. The stress analysis was then applied and simulated in the software, which provided data for the von Mises stress and the displacement of the spear.
To test the sides of the spear, an impact test was done. With the applied load of 250 newtons, a distributed force was applied to the blade edge of the spear point into the blade. The spear was clamped on the inside diameter of where the handle fastens with epoxy. For applied torque, a moment of 250 newton meters was applied to the body of the spear point in a counterclockwise direction. A restraint was placed in the inside diameter of the spear point where the handle is fastened with epoxy. The spear point was able to handle the required applied torque of 250 newton meters. To test the buckling of the spear, a distributed force of 250 newtons was applied to the handle of the spear point. A restraint was placed on the tip of the spear point to hold it in place. With the applied load, the spear point with the designated material of 4140 steel will not yield. To bring our design to life, we used 3D printing technology to create a prototype of the spear point. This allowed us to test the design and make any necessary adjustments before moving on to the casting process. It also served as a mold for the casting process. To attach the molds to a tree that will later be put into an oven, wax is used. The tree mold is then placed into a ceramic slurry that forms a coating over the mold. After this step, the mold is placed into an industrial oven where a 3D printed mold and wax melts, leaving a ceramic shell. Molten 4140 steel is then poured into that shell and allowed to cool. The ceramic shell is then blasted off and the spear is set off for heat treatment. This leaves us with our final step. Our final step is to take our spear and to grind it down so that all the edges are sharp. For the testing portion of our spear, the team decided to have the spear undergo a series of tests. The first of which was to test the sharpness of the spear against a watermelon. The sharp blade cut through the watermelon easily. The next step was to test the depth of the spear that would puncture the wet paper, simulating a hard surface. The average depth of the spear that punctured was 4 inches. To test against a different material, the spear was used to puncture a tin can, and the length was measured. The length punctured was 5.8 inches. The final test was to observe the twisting of a spear inside of the tin can. The spear twisted with ease, and the attachment to the handle held under the pressure. The team would like to provide a special thanks to SFSA, Acrecast, and Central Michigan University.